Hello folks, today I want you to present how to create a specific configuration. For example, in previous lessons we created an instances of LEDs and provided a pin number, physical input or output interface. So on Raspberry Pi we have a GPIO P3. For example, we have 40 pins and each of them except the specific pins with ground and voltages can be set up as input or output interfaces. So today I'm going to present you a configuration, because just imagine you can load a configuration from local resource or from internet, get it from REST API as a JSON response, and you can change any configurations anytime during your application is working as hot plugging. So one of the configuration could be as extension board with LEDs and buttons. Another configuration can be as a toy car with engines and video cameras and distance sensors, and you can replace it. It's very useful. Okay, let's do it. First step, we have to inject some dependencies for a JSON parser for Kotlin. So I'll copy some dependencies. It will be provided on README file on GitHub repository. Let's go to the remove it. Let's go to dependencies section and add two more dependencies. This dependency to parse, and this is a Kotlin modern dependencies. Sync XML. That's all, easy. The second step, we should to store somewhere our configurations just as files. So goes to main package, press new and directory. You can type a resources, but it's already exists here, so you can just choose it, and here you can see a resources folder. Let's create a simple JSON file like a lesson 03 config.json. What is a JSON file? Okay, JSON syntax, it's literally it's a text file what's providing through REST API through internet. So when you make some requests to remote servers, you can get a response, any useful information as a JSON syntax type. So this is a format of JSON file. This is a parameter, this is a value, this is a value, and this is the value what includes an array, a list of 1, 2 additional objects. So let's create some objects for it. Okay, we're opening JSON configuration, and let's start to think what we need for our configuration. Of course, it will be a config name, 2 dots, and like a lesson. Let's create a configuration with 2 LEDs. 2 LEDs. Okay. Comma and config description. Let's type something. This is a simple config with 2 LEDs. Yeah. It will be useful if we will know a version of our configuration, because we can extend it in the future or change it, like iPhone 14, 15, 16 and other types. Config version. It will be a text type. Okay. And hardware type, because if you want to change configuration during your application is working, like for example it will be a circuit diagram with extension board or something more real, like a toy car, air drone, or maybe you will create smart fridge, anything. So we can set a hardware type. Hardware type, like a circuit. Hardware model. Why not hardware model? Then more, specific will be your information, then less problems you will have in the future. So it's difficult to overload the config. Yeah. Okay, and you need a code version, because if you know something about hardware devices like laptops, the same model can have different hardware. It's something in the middle between type and hardware yearly release. So it could be the same model, but hardware can be a little bit different. So add hardware type code and model code to parse it in the future as well. Type code, we can provide hardware and model code. Model code. Yes. Then finally our LEDs. This will be a list of LEDs, so we opening an array marker and first object, name of our LED, green LED, and pin number, physical pin connector to control our LED. Perfect. And copy it. It will be the second red LED. Pin number 3. Okay, this is enough. Maybe just for a future, as example, we can add like buttons. Maybe our configuration will have some buttons. Okay, first object, name. We can copy it from here. Control button. Of course, it shouldn't be the same pin. And one specific parameter pull resistance. I'll explain later what it means. Resistance. Perfect. I believe that's all. So we created a JSON configuration. But how we can manage this configuration? We need a data object, a local model of this configuration, what we can get from local resources or from internet, from any remote server or service, anything. Okay, what we need? We need to create a configuration data class for it. Let me explain how it works. I know very nice plugin for IntelliJ IDEA. So JSON, it's already installed, but on my device. But just Google, go to settings, plugins, and install this plugin, JSON to Kotlin class. That's all. And after that, when you press right mouse button and choose new, you will have a new type. So if you want to create a Kotlin, here is it, data class, you can generate it automatically. Just copy your JSON file, call JSON Kotlin data class from JSON, paste your JSON information, choose name, configuration, yes, and a little bit settings I want to provide. Click advanced. Here it should be value. Always choose nullable, and here is init with here is non-null default no. Init with default value null. Yes. So we need this third parameter, and then goes to other and choose this parameter, enable inner class model, because if you will not choose it, it will generate a few separated data classes. We don't need it, we have to avoid it. So choose enable inner model, then press OK and generate. And look, it's gorgeous, it's beautiful. This is data class generated from our JSON configuration, what we just created from our mind. So the same, but I don't know, it's sorting from the alphabet, just replace it to the end. The same values as string and the buttons. Okay, perfect. Then, actually, the final step, we need to create some runtime working to parse this configuration from JSON dependencies. Okay, so first of all, we need to create an interface. If you don't know what is it, I'll explain in 1 minute. Okay, runtime configuration worker. This interface will return our valid configuration, and one function will be here, fun, get configuration. Oh, nice, AI filling it automatically. So get configuration, we just need one incoming parameter as file name. File name. It's a string. Yes. And we need to implement this interface. Okay. Copy the class of the name of the class, and create a standard class, Kotlin class, impl. So it's a runtime configuration implementation. What is the configuration? We extending our interface. Yes. And it's asking to override our methods. Perfect. What is an interface? So this runtime configuration parsing our configuration from local resource folder, but somehow in one moment we start to want to get configuration from internet. So it will be the same interface, but another realization of this interface. So we can create another runtime configuration implementation from remote source. Why we need a configuration? Because in our dependency injector, we just create one more function, get runtime configuration. We don't need this worker. Yeah, perfect. So look, it's type of this interface, but the realization of this interface is local configuration. But anytime you can change it, just provide another implementation of this interface. Okay, so let's create this configuration. First of all, we need a mapper, because to read the file, it's a byte mapper, byte array of local file. Okay, mapper JSON object mapper. Yes. Then we need to register some modules. First of all, register Kotlin model, because we use Kotlin. And register one more model. Register model Java time model. Yes, perfect. Let's start to parse our configuration in safety block from try. I'll explain later why we should do. Okay, JSON string. We have to read the string from file Java class loader get resource, provide a file name, what we receiving as incoming parameter. Actually, we don't need to provide this thing, it will work without it. Okay, then we have to map from text file to our configuration data class. How we have to do it? Well, JSON config type of our configuration equals mapper read value. Yeah, we provided all what we need. And of course, return JSON config. We have to open a catch block, extension, exception, then we can return here an empty configuration. If something will go wrong, we, as alternative way, we will return an empty configuration. It means we can't parse a configuration. Perfect. Let's get the configuration file on our main class. Here we need to create configuration. Perfect. How we have to init it? Go to init sanctions section and config equals our dependency injection get runtime configuration. It will return only our worker class, what will parse configuration, and inside this class we have to call get configuration. Okay, so get configuration and provide a class name. Our class name is lesson3 config.json. lesson3 config.json. Perfect. So our configuration will be parsed. Let's print it out. Print out somewhere here. Println our configuration. Let's launch it. Okay, it's deploying to the remote. Wait for Pi4J init After context, a little bit wait, looks perfect. So it means our green LEDs is blinking. We don't use this configuration. We still use an old model to init any physical devices and connections. We will do it in the next lesson. But look, our configuration, our program already know what configuration we provided to the code. Perfect. If we provide a wrong configuration, something like that, so the JSON file with this name doesn't exist. Look, the configuration is empty. All values is null. Let's return to the runtime configuration worker implementation. Why I put our parsing in the try block? If we exclude it from the try catch block, look what will happen. Okay, it works even without try catch block. Let's wait, yeah. But if we provide a wrong name, we will catch real-time exception. So Jackson library said us that it can't read value because incoming parameter is incorrect. In that case, we should to wrap it to the try catch block and return something alternative, markup of configuration. So congratulations, my congratulations, we extending our project step by step, and very soon it will be something very interesting. I already preparing some interesting thing to how to work with different sensors, with attitude sensors, with ultrasonic distance sensors. Now I'm discovering how to work with GPS satellite sensor. Perfect. So what we did today? We create a configuration. You can set here a lot of different configuration, like alternative config. Look, and here you can set just only one LED with different pin, like something like that, and you can switch between configuration in real time. I believe that's all for today. So yeah, more lessons will come very soon. Thank you for your attention and good luck with engineering.